Bismillahirrahmanirrahim. Assalamualaikum and very good morning. Welcome to my final year project presentation. My name is Zainul Ilman Bezana Abidin from College of Engineering School of Mechanical at University of Technology Malaysia Shah Alam. In this video, I will explain about my final year project, which is experimental setup for aluminium nanofluid with the added of TRITON X100 in the heat pipe system. I am supervised by my lecturer, Dr. Muhammad Fairuz bin Ramli. This is the content of my presentation.
First, let's begin with the introduction. Heat pipes are one of the most efficient methods of transferring heat or thermal energy from one location to another. It can transport large quantity of heat energy with small difference in temperature from the hotter region to the colder region by the working fluid. The working fluid that has been used in this experiment is aluminium oxide nanofluid. NANOFLUID is one of the effective way to work as a working fluid because the size of the particle is very small, which is less than 100 Nm. It can avoid from several problems such as abrogation and clogging. Other than that, TRITON X100 will be used in this experiment as a surfactant. Surfactant added to nanoparticle suspension is to help stabilize nanofluid and improve the distribution of suspended nanoparticle. Moreover, this addition can change the nanofluid transport properties such as viscosity and thermal conductivity. Then the system of the heat pipe will be designed to set up this experiment. The heat pipe will be made of copper because it has high thermal conductivity, corrosion resistant and long-term stable. This experiment will be used different concentration of nanofluid with the same amount of TRITON X100. The tested concentration of nanofluid is 0, 1 and 3%.
So, the main problem of the heat pipe system is the excessive heat that can make harm and damage to the device. It was necessary to remove the heat from the system. In this process, the heat from the evaporator will transmit into the nanofluid and will be cooled by the condenser. The use of nanofluid can make more heat can be transmitted compared to other working fluid such as water, oil and many more. Next, there are two objectives need to achieve from this project, which is to compare the amount of heat transfer in the heat pipe system when using different concentration of aluminium oxide nanofluid. Next, the second objective is to investigate how the surfactant TRITON S100 affect the thermal performance of a nanofluid when it is used in the heat pipe. The scope of the study is to measure the amount of heat transfer rate and determine the amount of temperature distribution across the heat pipe. This research also has its limitation. In this experiment, only one nanofluid will be used, which is aluminium nanofluid. It is because the price is low and easy to find compared to other nanofluid. Other than that, this experiment will be conducted only using same base fluid, which is pure water. Next, I will continue my presentation about the literature review. In the literature review, I will talk and explain about heat pipe performance, nanofluid, and surfactants. For the heat pipe, it is a simple device that can quickly transfer heat from one point to another. Besides, the heat pipe mechanism is used natural convection to absorb heat energy from evaporation process and release it at the condenser section. The heat energy is transported inside the heat pipe is known to operate in an evaporator region where in a fluid state. The heat transport inside the heat pipe is known to operate by evaporating a fluid at the heat pipe input section, which is evaporator, and condensing the vapor at the heat rejection, which is condenser. The heat pipe can be made using material of copper, nickel and stainless steel, while the working fluid, which act like a heat transport, are usually using a water, cesium, sodium, lithium and any other relevant type of liquid. The advantage of using heat pipe are a large quantity of heat energy can be transported through a small cross-sectional area over a considerable distance with no additional mechanical system or other power input into the system. For the nanofluids, it offers high thermal conductivity and heat transfer characteristic than pure fluid. The use of nanofluid in the working fluid is one of the methods for improving heat transfer. Particles with a diameter of less than 100 nm have characteristics that are different from those of a normal solid. According to past experimental data, a nanofluid containing water 5% copper oxide nanoparticle can improve heat conductivity by about 60%. Other than that, the size of nanoparticle can have an impact on thermal conductivity of nanofluid. As a nanoparticle size increase, thermal conductivity of nanofluid also increase. There are several types of nanofluid such as zinc, silver, copper, aluminium, and many more. In this experiment, aluminium will be chosen to study the amount of heat transfer in the heat pipe system. Depending on the previous research, the interface effect between material particle and the base fluid in nanofluid, aluminium nanofluid with pure water were found to be in good agreement with actual result. Next, the most effective way to increase fluid thermal conductivity is to use an additive. It can improve heat transmission is by lowering the surface tension of a working fluid. Surfactants are material that can reduce surface tension and capillary resistance. TRITON X100 will be used in this experiment. The addition of TRITON X100 improves starting and increased thermal performance by up to 35% according to the findings. The addition of TRITON X100 can reduce the surface tension and reduce the contact angle from 80 degrees in the pure water to 46 degrees in TRITON solution, making the fluid motion and boiling easier than in the pure water. For the methodology, it will be divided into 4, which is nanofluid preparation, experimental setup, experimental procedure, and equation to calculate heat pipe performance. For the nanofluid preparation, the nanofluid will be prepared with aluminium oxide nanoparticle and pure water as the base fluid. The nanoparticles are then dispersed in pure water and the solution is vibrate for 90 minutes in an ultrasonic machine. A catalytic chemical deposition approach was used to make aluminium oxide nanoparticle. Then, TRITON S100 was added and completely mixed by a magnetic stirrer. An ultrasonic homogenizer was used to mix the mixture. For the experimental setup, the two designs has sketched to show the process of this experiment. The air valve will be installed to allow excess air to be released when the working fluid at the boiling point. It also consists pressure gauge to monitor the pressure inside the heat pipe whether it is a vacuum or not. The heat pipe is a straight copper with a 300 mm length and 15 mm diameter. Thermocouples wire will be used as a temperature sensor. This experiment consists of 3 parts, which is evaporator, adiabatic, and condenser section. The temperature distribution along the heat pipe will be measured and recorded. In this experiment, the heat characteristic of the heat pipe will be measured for 3 different concentrations of aluminium oxide nanofluid. The heat pipe temperature will be measured by 4 thermocouples. All the thermocouples are connected to the digital temperature recorder using a connecting wire. 2 at the evaporator section, 2 at the adiabatic section, and 2 at the condenser section. Then, the heat transfer, temperature, thermal resistance, and efficiency will be measured using this equation. Lastly, for the expected result, the figure above show that the effect of nanoparticle concentration can affect the temperature of the wall of the heat pipe system. The temperature of the wall will decrease as the nanofluid concentration increase. It can speed up the heat transfer in the heat pipe system. For this experiment, the aluminium nanofluid will be mixed with the TRITON X100. The expected result for this experiment, the temperature of the heat pipe system will be lower than the figure above. It is because this surfactant can make the nanofluid more stable and can improve the heat transfer capability. That's all for my presentation. Thank you.